And good morning to y'all. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing the session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. So I want to talk about, eventually we're going to get to 14.2, and if we have any questions from 14.1, we'll look at those. But I want to talk about a couple of issues. So if you have a question that you want me to do in a Zoom session, try to let me know before about, say, 9 o'clock that next morning. And I've had some students send me emails like at 11:30 at night wanting help, and I didn't know if they were expecting me to be up and respond to them then or look at it the next day. And so I try to respond and say, you know, what do you want? But anyway, another thing, and I perhaps incorrectly assumed that people would pick up on this. So if an assignment is assigned, let's say on Monday, and it's due Tuesday night, that doesn't mean you should wait until 10 o'clock Tuesday night to start working on the assignment. You should try and get the assignment done the day that it's presented. Then if you have questions, you can ask them the next day to get it wrapped up by that night. Anyway, just wanted to clarify that in case some of you were wondering otherwise. Okay, so now, is there anything in 14.1 that anybody wants to look at before we go on? It was pretty straightforward then? Okay, super. All righty. So we're going to take a look at section 14.2, which is Arithmetic Sequences. All right. In one of my classes that I normally teach, Math 50, one of my typical assignments is to say, do every other odd problem, starting with problem number 1. So basically you would do 1, skip 3, then you would do 5, skip 7, then you would do 9, skip 11, 13, skip 15, 17, etc., etc. Okay, this is an arithmetic sequence. Now there's some notation that I want to introduce. The first term of an arithmetic sequence is called A sub 1, as in A with a subscript of 1. The second term in an arithmetic sequence is A sub 2, and then you have A sub 3, A sub 4, A sub 5, etc. The general description of a term is A sub n. Okay, so in this case, n would be 1 for the first term, 2 for the second term, 3 for the third term, etc. All right. Any questions about that notation? An arithmetic sequence has what is called a common, difference. In this particular arithmetic sequence, what's the difference between 5 and 1?
4.
What's the difference between 9 and 5?
4 as well.
Right, and I like the way you said as well. So here, the common difference, or D as it is used, is 4. All right. Now, from this, we can derive the following formula. And I'm going to go to the next page for this. And that is that A sub n, that is a particular term in the sequence, can be found by taking the first term plus n minus 1 times d, where n is the specific term that we're looking for, so here, and d is that common difference that I referred to. Okay, so just as an example, let's say that I gave an assignment that said, I want you to do every other problem starting with, or every other odd problem, starting with problem number 1. And I want you to do the first, I want you to do 22 problems in the assignment, okay? So then the question would be, okay, where do I stop? In other words, I could sit there and I could count. I could go, okay, I'm gonna do problem 1 and 5 and 9 and 13 and 17, and I could just count them up. But let's just say, for the sake of discussion, I want to know what the 22nd term is going to be. Okay. In other words, I'm going to know, oh, when I get to problem 87 or 33 or whatever, I can stop without even having to count them. So first of all, we need to know a sub 1, which is 1. And we need to know d, which is 4. So a sub 1 is 1 and d equals 4. So using this formula, the 22nd term would be 1 plus what? 22 minus 1 times 4. Any question about where or why I put numbers where I did? Okay, so this would be 1 plus what? 21 times 4, which is 1 plus 84, which is 85. So the 22nd term in that arithmetic sequence of starting with 1 and doing every other odd would be problem number 85. So the assignment would be 1, 5, 9, 13, ... up through and including 85. All right. Any questions about this example? This formula is one of 2 formulas that you will be allowed to have on a note card during the upcoming test. And I will mention that again. But this is the formula for an arithmetic sequence. Tomorrow, we're going to look at the formula for a geometric sequence, but let's worry about tomorrow. Anyway, so I want to use this formula to do some examples in the textbook. So here we go. This first set of directions says, write the first 5 terms of each arithmetic sequence with the given properties and find the specified term. All right. They tell us that the first term is 3. The common difference is 2, and they want us to find the 10th term. Okay, so it's an arithmetic sequence, and they haven't given us any other formula to use, so we're going to use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. We are to find the first 5 terms, so a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, and we are also to find a sub 10. Okay, now we're going to take the quick, easy way to find the first 5 terms, but we're going to use the formula to get the 10th term. So if the first term is 3, and the common difference is 2, then we're going to get 3, 5, 7, 9, 11. Any questions on how I got that? Now, I understand that you could say, well, to find a sub 10, it wouldn't be that hard because a sub 6 would be 13 and a sub 7, and etc. What if I asked for a sub 114? You wouldn't want to do it that way, would you? So the point is, let's use the formula to establish a sub 10. All right, so here's the formula we're going to use. So a sub 10 equals a sub 1, which is 3, plus n minus 1. N in this case is 10. So 10 minus 1 times d, which is 2. So a sub 10 is 3 plus 9 times 2, which is 3 plus 18, which is 21. So I found the first 5 terms and the 10th term in the arithmetic sequence. Any questions about this example?
So for 1, 2, 3, 4, and 5, you just add the difference. So if it was a 3, let's say it would be 3, 6.
Yes, yes, yes. Mhm.
Okay.
Yeah.
Okay, thank you.
You're welcome. Okay, let's take a look at another example. Let's see here. This one says, again, the same directions. We're to find the first 5 terms in the arithmetic sequence with the given properties and find the specified term. The first term is -5. The common difference is -3, and they want us to find a sub 15. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and finally a sub 15. So a sub 1 is -5. Since the common difference is -3, that means we're going to be adding -3 to each consecutive term. -5 plus -3 is -8. -8 plus -3 is -11. -11 plus -3 is -14. And a sub 5 would be -14 plus -3 is -17. Okay, so we did the same thing. In this case, we added -3 to each term to get the next term in the sequence. Okay, now a sub n equals a sub 1 plus n minus 1 times d. So a sub 15 equals -5 plus 15 minus 1 times -3. Again, any question about where I'm getting those numbers from? Okay, so this would be -5 plus 14 times -3, which is -5 plus, let's see, that's -42. So that would be -47. So here are the first 5 terms followed by the 15th term. Again, any questions there? All righty. Let's see. I think you've got that idea. Now we're going to look at a slightly different tweak on the same idea. It says the first 3 terms of an arithmetic sequence are shown below. Find the specified term. All right. So let's see. We've got a sub 1 is 2, a sub 2 is 6, and a sub 3 is 10. And we are to find a sub 28. Okay. Now, think back to the previous couple of problems. Here the difference was 2. To get from a sub 1 to a sub 2, what did we do? We added 2, right? 3 plus 2 is 5, 5 plus 2 is 7, etc., etc. Couldn't I also take a sub 2 minus a sub 1 to come up with a common difference? Or a sub 3 minus a sub 2 to come up with a common difference? So the common difference would be equal to a sub n plus 1 minus a sub n. Now, what is that saying in general? It's saying to get the common difference, take a term in the sequence minus the previous term. Okay, so here, the common difference, I could use a sub 2 minus a sub 1, so the common difference is 4. All right with that? Okay, now we know that d is 4. We know that a sub 1 is 2. Using the formula, a sub n equals a sub 1 plus the quantity n minus 1 times d. We get the following. A sub 28 is 2 plus 28 minus 1 times 4. Any question where I'm getting any of those numbers from? So this is equal to 2 plus 27 times 4, which is 2 plus, let's see, 80 and 28, 108, which is 110. So the 28th term in that particular arithmetic sequence would be 110. Any questions? Okay. Let's see here. Yes, question? No? Okay. All right. I'm going to tweak this idea a little bit more. It says, write the first 5 terms of the arithmetic sequence with the following properties. Okay. The first term, a sub 1, is 5. And the 5th term, a sub 5, is 29. They want us to come up with the first 5 terms. So they want a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Well, I already know a sub 1, and I already know a sub 5, right? But the piece that I'm missing would be the common difference. If I knew what D was, I could easily go 5 plus D is the next one, and then plus D is the next one, et cetera, et cetera. I know that a sub n equals a sub 1 plus n minus 1 times D. Okay. Now, things get a little bit trickier here. I know that a sub 5 equals 5, that's a sub 1, plus 5 minus 1 times D. Any questions as to where I got those numbers? I can simplify this and say a sub 5 equals 5 plus 4 times D. Again, 5 minus 1 is 4.
Okay, yeah.
Are we okay so far?
Mm-hmm.
But I also know that a sub 5 is 29. Well, if a sub 5 equals that, but it also equals that, then we can create the following equation. 5 plus 4D equals 29. Okay. Now I have an equation with one variable, D. Let's solve it for D. Subtract 5 from both sides of the equation. 4D equals 24. Divide by 4, D equals 6. Oh, now that I know that D is 6, 5 plus 6 is 11. 11 plus 6 is 17. 17 plus 6 is 23. 23 plus 6 is 29. Now, again, I know that you could sit there and spend seconds or minutes or hours figuring this all out, not doing it this way. Okay. But the point is to be able to use this kind of reasoning, this formula to do that. So I'm not looking for you to sit there and just trial and error do it. Okay. All right. Any questions on this example?
Could you do another one like that, please?
Absolutely. Let's see here. This one, the first term is -4, and the 6th term is -39. Again, they want to find the first 5 terms in the arithmetic sequence. So we're looking for a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Well, we already know that a sub 1 is -4. Okay. We're going to use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. Just something that, you know, I said that you'll be able to have that formula written on a card. By the time you're done with this assignment, you should have that formula memorized anyway, but even so. All right. Now, what do I know? I know that a sub 5, wait, oh, I don't want to use a sub 5. I know that a sub 6 is, that's a really sad looking a sub 6 is a sub 1 plus 6 minus 1 times d. Okay, now why did I use a sub 6? Because I'm also going to use that to say that it's equal to negative 39 like I did in the previous problem. So this means a sub 6 is negative 4 plus 5d. Okay, but I also know that a sub 6 is negative 39. Well, if a sub 6 equals that, and it also equals that, then we get the following equation. Negative 4 plus 5d equals negative 39. And we can use that to solve for d. Add 4 to both sides. 5d equals negative 35. Divide both sides by 5. d equals negative 7. Negative 4 plus negative 7 is negative 11. Negative 11 plus negative 7 is negative 18. Negative 18 plus negative 7 is negative 25. Negative 25 plus negative 7 is negative 32. And in fact, negative 32 plus negative 7 would be negative 39. So it works. You okay with that?
Yeah.
Do you need another example or can we go on to the next thing?
Can you do another one?
Yeah, one more.
One more, okay. Let's see. Do you want to do one that has a positive d or a negative d?
It don't matter.
It don't matter, okay. Let's do this one. The first term is 4, and the sixth term is 39. Find the first 5 terms. So a sub 1, we already know. A sub 2, a sub 3, a sub 4, a sub 5. Okay. We're going to use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. And we're going to use this. So a sub 6 is a sub 1, which is 4, plus n, which is 6 minus 1 times d. So a sub 6 is 4 plus 5d, but a sub 6 is also 39. So this equals a sub 6, and this is a sub 6. Therefore, 4 plus 5d equals 39. Did I already do this one?
Yes, except the 39 was negative. I believe the answer is
that's
7.
why it looks so familiar. Yeah. Okay. Yeah, there's only like 4 examples that they gave in the book, and I'd already done 2 of them. So anyway, subtract 4, 5d equals 35, divide by 5d equals 7. So we get 4, 11, 18, 25. Yeah, you're right. Okay. We okay with
I was
that?
going to speak up earlier, but I would have interrupted you.
That's okay. If you think like I've done something wrong or whatever, that's okay. Okay.
I see.
Tell you what, there is one other here that's different. We'll do that one. Sorry about that. I was asleep at the
worries.
wheel. Okay. The first term is negative 5, and the fifth term is negative 37. I'm just looking to make sure this one is at least slightly different. Okay, so a sub 1 is negative 5, a sub 2, a sub 3, a sub 4, a sub 5 is negative 37. Okay. So a sub n equals a sub 1 plus the quantity n minus 1 times d. We're going to use this. A sub 5 is a sub 1 plus 5 minus 1 times d. So a sub 5 is negative 5 plus 4d. But a sub 5 is also negative 37. So -5 plus 4D equals -37. Add 5 to each side. 4D equals -32. Divide by 4D equals -8. -5 plus -8 is -13. -13 plus -8 is -21. -21 plus -8 is -29. -29 plus -8 is -37. And woohoo, we've got our answers. Okay.
Yep.
All righty. Another situation. Do you know what a mean is? I don't mean like somebody's not nice kind of mean, but a mean is like a middle value.
An
So,
average.
kind of, not, well, yes and no, but it's we'll just say it's a middle value for right now, okay? Without getting into a lot of discussion about that, but so it says insert the given number of arithmetic means between the numbers. So this says 2 arithmetic means between 2 and 11. So 2 arithmetic means. So I'm going to say insert 2 arithmetic means between 2 and 11. So what that means is our first term is 2. Our last term is 11, and we're going to put 2 other terms in the middle. And for those to be arithmetic means, that means, a different word there, that this distance is the same as this distance is the same as this distance. Okay? So basically, we're going to have 4 numbers that are equal distance apart, because we want 2 arithmetic means. All right. Now, the key to this whole problem is that I've got my beginning number and my end number, and I want 2 numbers in the middle. So that gives me a total of 4 numbers. That's how I know that my last term, that is 11, is a sub 4. Now it's just like the last 3 or 4 problems. Okay, a sub n equals a sub 1 plus n minus 1 times d. A sub 4 equals 2 plus 4 minus 1 times d. A sub 4 equals 2 plus 3d, but a sub 4 also equals 11. Now, so what is it that I really needed to establish here? I needed to establish that 11 was the 4th term. They told me the beginning term and the ending term, but they didn't tell me at that point how many terms there were. This 2 lets me know that, oh, 11 is a sub 4. Once I know that, it's just like the previous problems we've done. A sub 4 is this, a sub 4 is that, so this equals that. Do you see how this is working?
Yeah.
One of you does? Well, that's good. Okay.
I think I might have solved it actually.
Well, good for you. 3d equals 9, divide by 3d equals 3. So this is 2, 5, 8, 11. And here again, you could sit there and through trial and error do it, but I could give you a massive problem that you'd have 2 hours of a headache trying to figure it out using trial and error. So the point is, these are simple problems. Use the formula to get comfortable with it, okay? I shouldn't say they're simple problems, but I could make them harder, but that's not the point. I want you to get used to being able to do this kind of situation. All right. New situation coming up. Insert the given number of arithmetic means between the numbers. It says 3 arithmetic means between 20 and 80. So we're going to insert 3 arithmetic means between 20 and 80. So I know that a sub 1 is 20. What's the subscript for 80? It's a sub what?
80 should be 5, right?
Yes. How did you get that?
There are 3 terms between the two numbers.
Exactly.
20 is one and 80 is another. Therefore, it goes up to 5.
There you go. So again, we know the first and the last, and we know there's 3 in the middle. So now we know that a sub 5 is 80. We're good to go. A sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 5 equals 20 plus the quantity 5 minus 1 times d. A sub 5 is 20 plus 4d, but a sub 5 is also 80. Therefore, 20 plus 4d equals 80. So really, these are just like the previous problems once we establish what the subscript on that last term is. So subtract 20 from both sides, 4d equals 60, divide by 4, d equals 15. 25 plus 15 is 35. 35 plus 15 is 50. 50 plus 15 is 65. 65 plus 15 is 80, and bingo. Okie doke. Let's see. Let's look at one that's not so nice. Okay. We want 3 arithmetic means between 20 and 30. So insert 3 arithmetic means between 20 and 30. So a sub 1 is 20. I've got 3 in the middle. So a sub 5 is 30. Okay. This is very similar to ones we've done, but the numbers d is not going to be as nice. Okay. So a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 5 equals 20 plus the quantity 5 minus 1 times d. A sub 5 equals 20 plus 4d, but a sub 5 also equals 30. So 20 plus 4d equals 30. We'll subtract 20 from both sides of the equation. 4d equals 10. Divide both sides by 4. d equals 10/4 or 5/2. Or I suppose you could write it as 2.5 or 2.5. Okay. Let's see. They give their answers as fractions, but I think as long as you give an exact answer, I don't know that WebAssign is going to care whether it's a fraction or a decimal. It doesn't seem to accept mixed numbers very well. It gets confused with that. At least that's in my experience with the ordered pairs and graphing. So this next number is going to be 20 plus 5/2. Let's do this. Let's turn everything into fractions, and then we'll simplify the ones that can be whole numbers. At least that's the way the book did it here. So 20 would be 40/2. So that's 40/2 plus 5/2, which would be 45/2. You see how I got from 20 to 40/2? Any questions there? Okay. 45/2 plus 5/2 would be 50/2. 50/2 plus 5/2 would be 55/2. And 55/2 plus 5/2 would be 60/2. Well, so a sub 1 is that, a sub 2 is that, a sub 3, what's 50/2?
25.
25. And then, so that's going to be a sub 3, and then a sub 4, and a sub 5. So 20 45 halves, 25, 55 halves, and then 30. And again, if you said what 22.5 and 52.5, those aren't wrong. I'm just, the book that the examples they use, they wrote them as improper fractions. And again, WebAssign, you can try and see if it accepts something other than that, but don't round something off. Okay. Let's see here. Let's do.
Can you show us how to enter those in WebAssign?
Sure. Okay. Give me a minute here. Let's see. So, student view. And come on here. So this is 14.2. And give me a minute here. Trying to find one that's got fractions. Well, okay. Let's see here. All right, so can you see the WebAssign?
Yes.
Let's take a look at number 5. Okay. It says, given the arithmetic sequence 2, 5, 8, 11, 14, 17, find a sub 3 and d. Okay, so what's a sub 3 going to be?
That'll be 8.
Yeah.
8, right?
8,
Yeah.
right? Okay. Now, what's the common difference?
Looks to be
3.
3. Okay. That one wasn't too tough, was it?
Mm-mm.
Okay.
I'm sure the worst is yet to come.
There you go. Always that case, isn't it? Now, here's where students get confused because I emphasized a specific formula for arithmetic sequences. But take a look at problem number 6. It says, write the first 5 terms of the sequence. It doesn't say what kind of a sequence it is, but it gives you what they want you to use right there. And students get confused because they ignore that and they just go back to the formula that I showed in class. Okay, so a sub n is negative 5n plus 2. All right, that's the formula we're going to use. So a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Let me switch screens. So where's my mouse? There it is. So a sub 1 is negative 5 times 1 plus 2, which is negative 5 plus 2, which is negative 3. Okay. A sub 2 is negative 5 times 2 plus 2, which is negative 10 plus 2, which is negative 8. A sub 3 is negative 5 times 3 plus 2, which is negative 15 plus 2, which is negative 13. Do you see how I'm getting that?
Yes.
Now,
I believe so.
I suppose at this point you could keep going, or what else could you do to get the last 2 at this point?
It looks like the difference between each one is 5.
There you go. Actually, not 5, but negative 5.
Oh, sorry.
That's okay.
Negatives tend to confuse me for whatever
Yeah.
reason.
But again, they're asking you to use that formula. So what are we going to put in there? We're going to put in negative 3. Let's see here. Negative 8. what is it, negative 13, et cetera, okay? All right, same thing here. Now,
I have a question.
just a sec. I just want to say,
Okay.
so just looking at these off the top of my head, I don't know whether some of them have fractions or not. And I think that might have been the question somebody was asking, why they wanted. So just looking at, okay, go ahead. What were you going to ask?
So for the a sub n equals negative 5n, did you substitute n for 1? Is that what happened? Because then
N,
it's a
n-
sub 1 equals, yeah.
Okay, this n is that number. It's the subscript.
Okay,
So,
yeah.
and so let's go back here.
Oh, okay.
The light just came on, folks. All right. Yeah, so here went there, this went there, this. went there.
Oh, okay.
Yeah.
All right, I got it.
This is one of those things that I know when you see it this
Okay.
morning, some of you are feeling, oh man, this is really complicated. It's
Yeah.
overwhelming. When you get off by yourself and you look at it, it's not that complicated.
Okay.
But it just seems like it's like, oh, he's performing magic here. No, he's
Yeah.
not at all. Not at all. Okay, let's go back and see what else we've got there. Looking at the assignment. I'm just trying to see if there's one that looks like it's going to have fractions. And I honestly don't remember. I even dishonestly don't remember which, if any of them have fractions in it. Let's see here. Let's do number 11. So,
I think number 7 has fractions.
okay, fine, we'll do 7. Have it your way, just like it. Okay. So let's see. A sub n is -1, the quantity to the nth power over 2 to the nth power. And we're supposed to find a sub 1, a sub 2, a sub 3. Ah, yeah, I see what you mean. Okay. So, go. The hardest thing for me to get used to in this whole deal is I have this tablet that's connected to the computer, but because of that, the mouse can go back and forth between the main screen and the tablet, but it makes it harder to get used to how to control the mouse, and it drives me nuts. Just wanted to share that. Okay, so having said that, I don't even remember if I went ahead and, all right. So a sub 1 is going to be -1, the quantity to the 1 power over 2 to the 1 power. Okay. So I'm putting that here and here.
Okay.
-1 to the 1 power is -1. 2 to the 1 power is 2. So a sub 1 is -1/2. Okay.
Okay.
Now, a sub 2 is -1, the quantity to the 2 power over 2 to the 2 power. Well, -1 squared is +1. 2 squared is 4, so this becomes 1/4.
Okay.
All right.
Making sense.
Good, because that's my story and I'm sticking to it. A sub 3 is -1, the quantity cubed, 2 cubed, -1/8. And finally, a sub 4 is -1 raised to the 4th power, which is 1/16. All right, so now let's go back and put those into the problem. Let's see. -1/2, I'm just going to go -1 divided by 2. 1/4, 1 divided by 4. -1 divided by 8. And 1/16. And let's see if it's right. Yay!
Yeah.
Now, let's see. I want to see something for a minute here. Okay, if I submit the answer now, what does it say? It won't let me go back, and I was going to try and put in decimals and see what it said,
Okay.
but it's not letting me do that in this particular mode. So, would it accept negative 0.5, 0.25, negative 0.125, and then 1/16? I don't think that's very nice, but I would just stick with the fractions. Okay. All right. Well, I'm going to call that a day. So I'll be back again at 1:15 if you have any questions. And again, if you run into problems that you want me to look at tomorrow during class time, please get them to me through email by, say, 9 o'clock tomorrow morning, so that I have time to get ready for that. Okay. Thank you so much. And we will stop the recording.